Okay, so on our third example, we have here a high school principal claims that the average performance of his graduating class in math was 83. To test this claim, 25 students were randomly selected from recent graduating class with the following results. So I'm not going to mention all these numbers. Okay, if you have your phone or if you may take a screenshot of this so that you may compute for its mean. You may pause it for a while and then we are going to compute for its sample mean and sample standard deviation. Now we are going to test the principal's claim using 0.05 level of significance. And our hypothesized mean is 83 because it is the claim of the principal. Now we are going to state the null and alternative hypotheses. So here we have the guidelines in constructing or stating the null and alternative hypothesis for population mean and the sample size is less than 30. Here we have the null hypothesis is equal to for our null hypothesis, the true mean is equal to the hypothesized mean, just like the z. And the alternate for our alternative hypothesis is it can be not equal, it can be greater than, or it can be less than. And since we are asked to test the principal claims or principal's claim, it means that we are just to check if there is a difference or if it differs from 83. So we have the null hypothesis as mean, or the true mean, is equal to the hypothesized mean, which is 83. It tells us that there is no difference between the true mean and the hypothesized mean. And for our alternative hypothesis, the true mean is not equal to the hypothesized mean, which is 83. We are to specify the level of significance alpha, sample size n, sample mean x bar, population, and or sample standard deviation. And since we are dealing with t and the sample size is less than 30, we are going to compute for the degrees of freedom. Alpha is 0.05. The sample size is 25. And for us to compute the degrees of freedom, we are just to subtract 1 to our sample size, which is 25. Meaning to say the degrees of freedom is n minus 1 or 25 minus 1 equals 4. Our sample mean is 82.92 and the sample standard deviation as I compute is 4.6. Okay, so these two are based on my computation. We are going to choose the test statistic and that will be t equals sample mean minus hypothesized mean all over the sample standard deviation divided by the square root of the sample size. We are also to determine the critical region and state the decision rule. That will be our step number 4. Now, if we are going to recall this slide, it tells us here what will be our decision rule. We all know that our alternative hypothesis is the mean, or the true mean, is not equal to the hypothesized mean. Hence, our decision rule will be reject the null hypothesis if the computed or the absolute value of computed t is greater than or equal to the critical value of t. Okay? And this one, n minus 1, is the degrees of freedom, while this 1 minus alpha over 2 is the percentile. And we are going to use this test statistic. Now let us take a look at our t-table. So how are we going to find the critical value of t? If we are going to recall, our degrees of freedom is 24, right? And our level of significance is 0.05. If our level of significance is 0.05, the level of confidence will be 95%. So meaning to say, we have 24 as the degrees of freedom, and the level of confidence is 95. It goes to show that the critical value of t will be 2.064. Now, determine the critical region and state the decision rule. So we are going to reject the null hypothesis if the computed or the absolute value of computed t is greater than or equal to 2.064. And we are not to reject the null hypothesis if the absolute value of computed t is less than 2.064. And illustrating what we have, here we have on the right side the rejection region. Since it is two-tailed, we have a rejection region on the right and a rejection region on the left. And its boundaries are 2.064 and negative 2.064. If the value of z falls under this white portion, therefore we're not going to reject. But if it falls under the pink or the rejection region, pink portion, we are to reject the null hypothesis. So let us compute the value of t. X bar, if we're going to recall, 82.92. The hypothesized mean is 83. Sample standard deviation, 4.6. Sample size, 25. Or we're going to divide 4.6 by square root of 25, which is 5. What's next? So the absolute value of t is 0.087. Or shall I say that this one is negative, but since we are asked for the absolute value, I make it positive. Okay? Obviously, 0.087 is less than 2.064. Therefore, the null hypothesis is, but before we answer that, let us recall. Are we going to reject the null hypothesis, or are we not we are not going to reject the null hypothesis? Okay, 0.087 or negative 0.087 is, or are here, okay, in this portion, it is close to 0, and it is very far from our rejection region. It falls under the non-rejection region. And if we're going to recall the decision rule, we are going to reject the null hypothesis if the absolute value of computed t is greater than 2.064. But is it greater than? Okay. It is not greater than. That is why the null hypothesis is not rejected. Okay? We are not to reject the null hypothesis that there is no difference between the true mean and the hypothesized mean. Meaning to say, we do not have sufficient evidence to reject the claim that the true mean is different from the hypothesized mean, which is 83. And that will be for the third example. And now if you find this video helpful and you like this video, don't forget to subscribe, click the like button, and hit the notification bell so that you will be updated to our next videos.